Have you ever really, truly stopped to think about numbers? I mean, not just for counting stuff, but about this huge, hidden universe they represent. Well, today we're going on a guided tour of that universe. It's a place you actually visit every single day, probably without even realizing it. So let's start with the big question. Why are there so many different kinds of numbers anyway? Why isn't just, counting good enough? Well, the answer is actually pretty simple and kind of beautiful. Every single time a new type of number was created, it was because we came across a brand new problem that the old numbers just couldn't solve. To really get this, we've got to go way back, right back to the very beginning. Our whole journey starts with one of the most basic human needs, to answer that super simple but super important question: how many? And that question leads us to the first most intuitive set of numbers out there, the natural numbers. You've known these guys since you were a kid. They're the positive numbers we use for counting, right? 1, 2, 3, 4, and on and on and on, forever. We use them everywhere, all the time, without even thinking about it. Counting apples in a basket, sheep in a field, the days in a year. They might seem simple, but believe me, they are the absolute bedrock of all of mathematics. Okay, but even this super simple fundamental set has a problem, a limitation. It works perfectly when you have something to count, right? But what about when you have nothing? How do you write down the number of apples in an empty basket? To solve that little puzzle, humanity needed a brand new invention, a number that means nothing. And by adding this one idea, the concept of zero, to our natural numbers, we suddenly created a new set, the whole numbers. It seems like such a tiny change, but it was absolutely revolutionary. And this shows you a really cool idea we're going to see over and over. Our universe of numbers is expanding, kind of like one of those Russian nesting dolls. The new set, the whole numbers, contains all of the natural numbers right inside of it. And believe me, we are just getting started. So we can count things, and we can represent nothing, but what about owing something? What about debt? Let's see how our number universe has to expand yet again to solve this brand new problem. So here's the next challenge for you. Let's say you have $5, but you need to spend 7. How do you represent that? Our current set of numbers, the whole numbers, they just can't do it. They have no way to describe the idea of debt, of having less than nothing. The solution? Well, it was to introduce opposites. For every positive number, we suddenly invented a negative counterpart. And this new expanded set, all the whole numbers plus all their opposites, we call those the integers. And bam, suddenly, with this one invention, we could describe so much more about the world around us. A debt of $2, that's just -2. A freezing temperature, -10 degrees. That parking garage 3 floors below ground, you got it, -3. Integers gave our number line a whole new direction. Okay, time to check back in on our expanding universe. We've just added another layer to our nesting doll. The integers now contain all the whole numbers, which of course contain all the natural numbers. See the pattern? All right, our number line is starting to look pretty full. We've got 0 in the middle. We've got a whole bunch of positive numbers stretching out one way and an equal number of negative ones going the other. But if you look really, really close, what about all those gaps in between them? What about the numbers that aren't whole? Think about it in the simplest possible terms. How do you split one pizza between 2 people? You can't give each person an integer amount of pizza. We needed a whole new kind of number to talk about parts of a whole. And the answer to our pizza problem is the rational numbers. Now, don't let the name scare you. It just comes from the word ratio. A rational number is simply any number that you can write as a fraction, one number over another. And this includes all the integers we already know, but also every single decimal that either stops, like 0.5, or repeats in a pattern forever, like 0.333. And with the rational numbers, our universe just got incredibly crowded. They fill in all those infinite little gaps between the integers. And of course, our nesting doll gets its biggest layer yet, containing every single set of numbers we've talked about so far. So at this point, you're probably thinking, okay, we're done. We can count, we can handle debt, we can slice things into perfect fractions. The number line seems totally complete. But it's not. There are still some really strange, kind of wild numbers hiding out there in plain sight. You see, on one side, you've got these nice, orderly, predictable, rational numbers. You can always write them as a neat little fraction. But on the other side, you have the irrational numbers. And these guys,
they just refuse to play by the rules. You can never write them as a simple fraction, and their decimals go on forever without ever repeating.
The biggest celebrity in this group is, of course, pi. Yeah, we usually round it to 3.14, but its true decimal form just keeps going forever, with no pattern at all. It's a totally different kind of number, one whose digits never fall into a nice, predictable loop. Another famous one is the square root of 2. They're absolutely essential, but they just defy that simple order of fractions. So now we have these two totally different families of numbers. You've got the predictable, orderly rationals, and then you have the infinitely complex, patternless irrationals. So how do these two opposites fit together? Well, when you combine them, you finally get the complete picture. When you put all of them together, you get the real numbers. This set combines every single rational and every single irrational number. If you can point to any spot on the number line, any spot at all, no matter how small, that's a real number. The line is now, finally, truly complete. And what a journey it's been, right? We started with just needing to count, which gave us natural numbers. The idea of nothing gave us whole numbers. The need for opposites and debt created the integers. Slicing things up led us to the rationals. And finally, discovering the numbers that just broke all the rules revealed the irrationals. Every single step was a solution to a brand new problem. And that is our tour of the real number line, a line that seems to hold every single number you could possibly need to describe the world. Or does it? Because think about it. Our entire journey has been along this one single line. We've mapped out all the real numbers, but what if there are numbers that don't even exist on this line at all? What if there are imaginary ones? Now that is a question for another explainer.